user-friendly. All right, so we're going to skip over that piece. Okay, so realize the notes I printed are a little different than your guys. So, okay, so the next thing we're going to talk about is something called betweenness. Doesn't that sound like a made-up word that like someone like doesn't sound right? Like it's like extra, too many syllables or something. Betweenness, maybe not too many syllables, but too many pieces of words. So we're talking about being between, and then we add betweenness. Any idea of what you think betweenness means? Kind of like, again, a strange word. So the idea of betweenness is when they're talking about something being between something else. So when we're talking about points being between one another, it has to be also collinear. So if I'm trying to I'll use Nolan and Izzy as an example right now. There's no one between them. So even though Bella is kind of like, I could kind of go that way with her, since she's not collinear with them, she is not between them. Now Bella is between Dawson and Peyton. So Bella is between them. So in terms of betweenness, Peyton and Dawson, Bella, and also Will are between them. Whereas between Nolan and Izzy, there's no one between them. So the word betweenness, it's really important that you know that the lines are collinear, or the points are collinear. So they first have to be collinear, and then obviously be between. I hate using the word itself in the definition. So someone give me a point between A and R. A and R. Give me a point between A and R. Go ahead, Drake. N. So N is between A and R. Sorry, A is a little. Would P be between A and R? No, because P is not on that same line. So that's a vocab word they use in this section. They'll sometimes use it to have you draw a picture. So like they want you to draw a line where something's between something else. And so P in this case would not be between. So if I was trying to draw that, that wouldn't be a good example of one that's between. All right, so next vocab word, we're going to talk about congruent segments. The word congruent is a geometry word. I don't know why the algebra people and the geometry people didn't get together and kind of use the same words. Does anyone know what congruent means? Congruent. Means the same thing as equal. I don't know why they just don't use equal, but again, I don't know if geometry and algebra were figured out in two different like parts of the world when communication wasn't great. So congruent segments are equal segments. So if they say two segments are congruent or two angles are congruent, that means they're exactly the same length or the same size. So they're exactly the same length. So that means if they give me two congruent segments, I can just set those two segments congruent or set them equal. So I'm able just to go ahead and set those equal. So I don't know if you guys have a little bit of space, maybe right above or right under. I guess you guys do have a little bit of. So if they tell me you guys want to do a quick little example here with me. Actually, 3x. Now, one of the things we'll do in geometry to show you guys something is equal. I can't just say, well, those look equal, so I assume they're going to be the same. They look the same size. They're going to make these little marks on the lines. So to show congruent segments, they use what we call tick marks. So if they have those little tick marks, that tells you they're equal. So those little lines, a lot of times they use red or blue or something in the book that's pretty clear. If they have little marks like that, that means they're going to be the same length. So we can assume now then that AB and CD are the same length. If they don't tell us that, we can't assume anything in geometry. You can't say, well, that looks close enough, I'm going to say they're equal. You don't want to grab your trusty ruler and pull that out and measure that because, again, the book isn't asking you to measure it here. They're saying what's the length of them. So if they say they're marked equal, that means we can set those two equal to each other. So I can say that AB has to be the same as CD because of those little marks. If I know that, then I can just set those expressions equal to each other. So I can say 2x plus 1 equals 3x minus 7. Do we know how to solve a problem like that? If you passed algebra, you should have. So if you made it out of there, you should be good. What do you guys want to do? You do it here. What do you think? Peyton, what do you think we should do first? Subtract the 1. I maybe move the other way. Go. So move the 7, or I'd move the x's around. So I'm going to add 7. A lot of times with these, I do a little bit of forward thinking, like a little bit of a chess match here, trying to think what's going to happen next. I like to avoid having negative variables, so I'm going to move that 2x instead of moving the 3x. So I'm going to get 8 equals 3x minus 2x, which is just 1x. So 8 is x. Now, what if I wanted to know what the length of AB is? Can I figure that out now? What if I said, how long is AB? Yeah. Yeah, now we know what x is, so we could put that in for x and figure out the length of AB and the length of CD, which should be the same length. This is a great example of why we want to check our answers in algebra. You put this back in 2 times, so if I want to know what AB is, I'm going to do 2 times 8 plus 1. So it's going to be 16 plus 1, so that's going to end up being 17. And if you want to double check that you did that correctly, you could put it in here. 3 times 8 is 24, minus 7 is also 17. So AB and CD ended up being the same. All right, so this is going to stop the first half of the video, and we'll come back to the second here. We're going to take a little break here.